antiderivative as a differential equation with particular values. So we are given uppercase f of x as the general antiderivative of a given function f of x equals 5 minus 3x e to the x over x. And also given f of 1 is e, we need to find the function uppercase fx. So first we simplify. We have 5 minus 3x e to the x over x, so we can write 5 over x minus 3x e to the x over x, so x will cancel out in the second term, so we get 5 over x minus 3 e to the x. Now when you take the antiderivative general, then we get uppercase fx will be 5 natural log of absolute value of x minus 3 e to the x plus a constant. Now let us use the conditions we have. We have one condition only, f1, which is 5 natural log of 1 minus 3 e to the 1, or just e plus c. Now you know natural log of 1 is 0, so that terms drops. So you get f of 1 is given as e. So we have negative 3e plus c, that gives me c equals e plus 3e will be 4e. So then we got our function uppercase f of x, which is 5 natural log of absolute value of x minus 3 e to the x plus 4e, which is the value of c. And we are done for this problem. Example 2, we are given a function ft. So when you take the antiderivative of lowercase ft, that will give you uppercase ft. So we know the derivative of tangent x is secant squared, so antiderivative of secant squared will be tangent. So we write 7 tangent x minus 3 t squared will give you t to the 3 over 3 with the power rule, 4t plus a constant. Now replace the t value, which is 0, so f0 gives me 7 tangent 0, and it should be t, not x, because we are working with the function of variable t. 3 will cancel out, so you get t to the 3 is again 0, then this is also 0 plus c. So f0 is 10, tan 0 is 0, so everything goes 0, so we got c equals 10. So now the function we are looking for will be 7 tangent t minus t to the 3 plus 4t plus 10. So we are done for this problem. Example 3, we have double derivative of a function, which is 6x plus sine x, and with the initial conditions we have f0 is 1 and f prime 0 is also 1. We need to determine the main function. So first of all, you have second derivative. If you take the antiderivative of second derivative, then you get one step backward, which is our f prime x. So then antiderivative of x will give me x squared over 2. Then you get 6 times x squared over 2. Antiderivative of sine x is negative cosine x, and we add a constant. Now replace the condition here. We have when x is 0, we get f prime 0. So x is 0, so this term goes away, minus cosine 0 plus a constant, and f prime 0 is 1, cosine 0 is also 1, so you get a negative 1 here plus c. After simplification you get c equals 2. So then you got your f prime x as 3 x squared minus cosine x plus 2. Now again, if you take antiderivative, so you get your function back fx. So 3x squared will give you now 3x to the 3 over 3 minus antiderivative of cosine will be just sine x plus antiderivative of 2 will give you 2x, and add another constant here. Now use the condition we have f0. So when it's x is 0, we get this term cancelled out. X to the 3 also, when x is 0 is 0, sine 0 is 0, 2 times 0 is 0, plus a c. And since f0 is 1, so we know that tells me c equals 1. So then we have got our function f of x, which is x to the 3 minus sine x plus 2x plus 1. Example 4, we have third derivative of a function with two conditions. So using antiderivative, first we get f double prime x is e to the x plus c. Now use the condition, we get f double prime 0 is e to the 0 plus c. E to the 0 is 1 and f double prime 0 is given as 5. So then you see your c equals 4. So then we got our f double prime x equals e to the x plus 4. Now further antiderivative will give me f prime x, which is e to the x plus 4x. We add another constant from this. So then use the second condition we have, f prime 0. So f prime 0 is e to the 0, 4 times 0 plus a c. So f prime 0 is given as 4, e to the 0 is 1, and this goes away, plus c. So from here we see c equals 3. So we got our f prime x as e to the x plus 4x plus 3. Now when you take again antiderivative, we get fx, which is e to the x plus 4 x squared over 2 plus 3x plus another integral constant. Now in fx we do not have any other condition, so in our answer we just leave our c. So the final answer we end up with f of x equals e to the x plus 2x squared plus 3x plus c. So this is our final answer.